Today we'll be going through AWS and Terraform. Our goal is to deploy VPC in AWS using Terraform with one private subnet and one public one. So let's hop into the console and work on that. Alright, so I'm already logged into our AWS account, and let's firstly navigate to VPC. We will check how our current infrastructure looks like. So we have one VPC deployed, a default one with a CIDR of 172 and few subnets, a public and private ones in different availability zones. So let's hop into Ubuntu server, which we installed before. If you weren't aware of this particular hands-on, I will link it down below. And the second thing, let's go to our Terraform, which we already instantiated before. I will link it also down below. So here we have our Terraform code. So we have our providers.tf, which has AWS provider and AWS region set to US East 1. And we have our main.tf, which only consists of an S3 bucket, which we created in previous videos. So right now, we would like to go to this main.tf. I will use nano. And we would like to create a VPC. There is quite a lot of code to create VPC, subnets, NAT gateway, internet gateway, and so on and so on. So I already prepared that for you, and it will be a part of our today's blog post on briefly.dev. So let's just copy all of that and we will go through that. That will make more sense than you waiting for me to type all of that. So let's paste it here and let's go up to the beginning and see what we will be creating. So first of all, we will do a resource AWS VPC. We will call it a main VPC, and we will take a CIDR block of 10.0.0.0. Remember that the actual CIDR block which is deployed in this account is 172.31.0.0. So then in this VPC we will create a subnet. We will use resource AWS subnet and we will create a public one. VPC ID we will take out of it. So we will do a connection to AWS VPC resource .main VPC, so to this one, and .id. This is what we are taking. And we are giving a CIDR block of our public subnet to 10.0.1.0/24 and map public IP on launch. This is to add IP addresses, public IP addresses to this subnet. And there is a tag, so we will have a name of public subnet, which will be shown here. Another thing, private subnet. So private subnet looks the same, but we will not map the public IPs, and the CIDR will be 10.0.2. Another thing which we need to will create is an internet gateway. So for the public subnet which we want to create here to have access to the internet, we need to create an internet gateway which will allow for that. So we will create a resource of AWS Internet Gateway and call it main EGW. Another thing we need to do is to create a route table. So route table for public one. So we will make it exposed and open to the internet, fully public one. So to all IPs in the internet, we want to route them through Internet Gateway, so it will have connection to outside and from the internet to the public route. Then to attach it, we need to do something called table association. So we will take this newly created route table AWS write table resource dot public rt, so we are referencing this dot id, and we are assigning this route table to the public subnet which we created. So AWS subnet resource dot public subnet dot id, and that will create this connection of route table to subnet id. Another thing, this will be already a part of private subnet in the future. So we want to create something called AWS NAT gateway. We will use it to give internet access from our private subnets. So if we would, let's say, deploy EC2 in a private subnet, it would have access to internet, let's say, for a connection to some kind of external database, or let's say doing even updates or whatever, but it will have a private IP. So from outside the private subnet, you won't be able to access this instance. So we are creating AWS NAT gateway, calling it main NAT, and we are making an allocation of elastic IP, which we are creating here. So we will create ourselves an elastic IP to which we will attach to this NAT gateway so that it has access to the internet, and we will make a correlation to the public subnet, so it will take the internet from internet gateway attached to this public subnet. And here we have a clause depends on, so this elastic IP needs to be created first, because in order of operations we cannot create NAT gateway if we don't have a elastic IP created yet. So depends on is used for Terraform to make some kind of a chain of operations. So this tells Terraform that, hey, you need to firstly create ourselves an elastic IP, and then you can go to create NAT gateway because you depend on this elastic IP being created. So then we have another route table which will be attached to our private route. So we will also do the 0.0.0.0/0, so access to the internet, but it will go through NAT gateway, not the internet gateway. And then we are giving it a name so that we can easily check that in the console. And the last thing we will do is another route table association. So to private subnet, we will attach the route table of private RT, which we are creating right here. So let's write all of that. Let's do Terraform FMT to format the code if anything needs to be formatted, like the indents and so on. And then let's do Terraform apply. We will need to wait a moment for the states to check. As you can see, it's checking this bucket. Okay, let's go from the top. So we have our plan here. AWS S3 bucket was checked. The state is okay, so we won't be creating that. But here are all of our resources. So we are creating elastic IP, as we said. We are creating NAT gateway. We are creating IP, internet gateway. We are creating private route table and public route table. We are creating the associations, and we are creating private and public subnet, and we are creating VPC. So we will be totally adding 10 elements. So let's do here, yes, I want to approve that, and let's wait for it to finish. If it would take quite some time, I will speed up the video. Alright, and we are back. It took like 2 or 3 minutes to deploy, and let's go to AWS and go to our VPCs. And let's refresh that. And as you can see, our main VPC with CIDR of 10.0.0.0 was deployed. Let's go to Subnets, Let's refresh that. And we have our two new subnets, which we called public subnet and private subnet. Let's go to route tables. We have a private route table and public route table. We can see here that we are in private route table and all the traffic to the internet is being routed through NAT gateway, which we created. And in our public route table, all the traffic is going to internet gateway. And we will go to elastic IPs, and this will be this one elastic IP which we created and associated it with the NAT gateway we created here. So that's the basic idea behind deploying VPC with private subnet, public subnet, internet gateway, NAT gateway, public routes, table routes. Next time we will use all of this data to utilize more of the AWS resources through Terraform. So we will be able to take EC2 and deploy it in this VPC and this in the particular public or private subnet, and then we will check if everything works, if we have the connectivity to internet or outside of the VPC itself. So in public subnet, can we access the EC2 instance from the internet itself? So see you next time. There is a lot of more to learn in AWS and Terraform. See ya.